You know when you're on a call and your voice travels across the world in an instant? Well, that's all thanks to something called a codec, which handles speech compression. And a huge new breakthrough is making that whole process smaller, smarter, and just way more efficient. Let's get into it. You see, here's the central problem that engineers and AI researchers have been wrestling with for years. When you try to compress speech, you're always in this constant battle. You got to shrink the file size way down, but you absolutely cannot lose the quality of the sound, or maybe most importantly, the actual meaning of the words being spoken. And this brings us to what's called the codec conundrum. For as long as this has been a thing, you've had to choose. You could have a super small file, but maybe the voice sounds robotic and tinny. Or you could have that beautiful, crystal clear audio, but the file would be massive. Getting all three, a tiny file, clear sound, and words you can actually understand, that's been the holy grail.
So to even try to get around this, older technologies use these incredibly complex systems, sometimes juggling multiple dictionaries of sound. But it was always a compromise. You were always giving up something either on size or on quality.
But what if you didn't have to compromise? What if you could have it all? That's exactly where this new research paper comes in, introducing a technology called FocalCodec. So the work is called FocalCodec, Low-Bitrate speech coding via focal modulation networks, and it comes from a team of researchers, Luca Della Libra, Francisco Paisan, Cem Subukan, and Mirko Ravanelli from some amazing institutions like Concordia University and Mila. And what they're proposing is a totally new way of looking at this problem. Their goal was, frankly, ambitious, to completely shatter that old trade-off. But here's the real kicker. They wanted to do it with a simpler, more elegant design. One that relies on just a single codebook. So it's not just about being better, it's about being less complicated too. Okay, so how in the world do they manage to pull this off? Let's dive into the secret sauce and see what really makes FocalCodec tick. All right, at a glance, this is the architecture. You've got raw audio coming in on the left, it gets processed through the middle, and then the restored audio comes out the other side. That discriminator up top, you can think of it like an expert judge, constantly giving feedback to help the system learn to make the output sound more and more human. Let's walk through that main pipeline. So big picture, it's a 5-step journey. The encoder listens to the audio and figures out its most important features. Then, the compressor and quantizer work as a team to shrink those features into these tiny, efficient little digital things called tokens. And finally, the decompressor and decoder take those tokens and rebuild the audio. But the real magic is in how they do it. The first really big innovation here is something called focal modulation. Okay, think about an artist sketching a portrait. They don't start by perfectly drawing one single eyelash, right? No, they sketch the whole shape of the face first to get the context, the proportions. Then they zoom in for the fine details. Focal modulation does the exact same thing for sound. And this big picture first approach is incredibly efficient. It means your phone or computer doesn't have to work nearly as hard. The second piece of genius is how it creates those digital tokens. It uses a method called binary spherical quantization, or BSQ for short. Now, instead of having some massive pre-made dictionary of sounds it has to look through, BSQ basically creates one on the fly, using a series of simple, think yes or no choices. It's super lightweight, and it means every single part of its sound vocabulary gets used. Nothing is wasted. Okay, so the theory is brilliant. You've got a simple design, two really powerful new ideas. But does it actually work in the real world? Let's take a look at the results. Get ready for this number. One version of FocalCodec can shrink speech all the way down to 0.16 kilobits per second. That is unbelievably low bitrate. We're talking about pushing the very edge of what anyone thought was possible for high-quality speech. But is the audio still clear at that tiny size? Well, this chart says it all. This shows the word error rate when there's background noise, and lower is better. Now look at FocalCode compared to a top competitor, BigCode. It makes less than half the mistakes, even while using way less data. So it's not just smaller, it's actually easier to understand. And this isn't just an English-only thing. When they tested it on speech from multiple languages, it's the same story. Once again, FocalCodec gets a lower word error rate, which means the words are just plainer clearer, all while doing an amazing job of preserving the unique sound of the speaker's voice. But, this is where things get really exciting. Because just compressing audio is only the beginning. Those high-quality digital tokens that FocalCodec creates, They're like these super-powered building blocks for a whole universe of other AI applications. I mean, we're talking about using these tokens to power incredibly realistic voice cloning, building better speech recognition so your phone actually understands you, cleaning up noisy audio on a call in real time, identifying speakers, even generating brand new human-sounding speech right from text. In fact, the paper itself points out that for a really tough task like voice conversion, FocalCodec just nails it, achieving the highest similarity to the target speaker while making sure you can still understand every single word. So let's just step back for a second here. A new, efficient codec is cool, for sure. But what does all of this really mean? Why is this such a big deal for the future of, well, everything that involves a voice? It really just boils down to three huge takeaways. First, efficiency. You're getting state-of-the-art quality at file sizes that were basically science fiction before. Second, simplicity. That single codebook design is so much less complicated, making it way easier for other AI models to use and build on. And third, versatility. This is not a one-trick pony. It's a foundational technology that can lift up dozens of other applications.
So, what does this mean for you? Well, this kind of crazy efficiency could power the next Siri or Alexa that lives right on your device, no cloud needed. Or it could bring crystal clear voice calls to people in rural or remote areas that have really spotty internet. It's all about making high-quality speech accessible to everyone everywhere.
And all of this leads to one final, really fascinating question. FocalCodec is a massive leap forward in just how efficient AI can be. So as this trend continues, as AI gets smaller and faster and smarter, it just makes you wonder, right? Where are we going to hear it next? In our cars, our smart glasses, or in some application that nobody's even dreamed up yet?